Calculating weighted averages. The best way to use this video is to watch a slide, pause, go see if you can do the calculations yourself, and if you can, then proceed. Let's start this discussion with a review of the arithmetic mean. A mean basically is the old average we know how to do. Add up all the values and divide by the number n, the number of values there were. A weighted average is similar to the mean, except that it adds a weight to each of the values. And instead of adding up or counting up the number of values to use to divide by, you use the sum of the weights. If you think about the mean and use a weight of 1, the weighted average formula actually works out to be the same as the mean. If you're unfamiliar with the sigma notation, it means sum of. You should have seen that in your prior math classes, but if you haven't, there are some great websites, including the Math is Fun site and the Wikipedia page on summation. For example, you're operating a pizzeria and you want to calculate the weighted average of the temperature of your pizza oven. On our statistic here, on our example here, we have had a temperature of 475 degrees on 5 days, 480 degrees on 3 days, and for 2 days it was measured at 455 degrees. We can use the number of days as the weight to multiply each of the values by and then sum up the weight at the end to divide. And you can see in the example, we take 475 times 5, 480 times 3, and 455 times 2 and divide it by 10, coming up with a weighted average temperature in our pizza oven of 472.5 degrees. Weighted averages are often used to balance estimates, expectations, and predictions. If we have, for instance, 3 predictions that each have a percentage likelihood of happening, we would use the weighted average to come up with the weighted likelihood and the weighted average. For instance, we have 3 cost estimates. One is that it's a 20% chance of costing $1.7 million, a 50% chance of it costing $2.5 million, and a 30% chance of it costing $2.6 million. Because these estimates are in millions, fractional millions, tenths of millions, I went ahead and calculated it using that instead of adding all the zeros. So our weighted average would be $2.37 million. I'd probably look at management if I were the person doing this estimate and say, that's probably about $2.4 million, because we can round the 2.37 up, and it's just a guess anyway. If you stop and do the mean of those 3 values, though, you would come up with a $2.25 or $2.26 million, which probably would come in too low. In our third example, we have a table of values and their weights, and I wanted to kind of show doing it as if we were doing it with a spreadsheet. The first step in the process is literally to calculate the value times the weight, and you can see I added a new column to my table to calculate the value times the weight. Step 2 in this problem would be to calculate the sum of the weights and the sum of the value times the weight, giving us a sum of weights of 1.0 and a sum of the value times the weights of 38.6. Step 3 is just to divide the sum of the products divided by the sum of the weights. And because the weight is 1 in this example, the weighted average is 38.6. This concludes the video on weighted averages. If you have any questions, you can consult the book, you can consult me during office hours, or you can go out and search on the Googles and see if you can't find other examples, including the one at Math is Fun and the one at Wikipedia.